In the previous video, we covered the basics of the SqExpress library. In this video, we delve into more advanced techniques. Our plan is to dynamically read table metadata from an existing MS SQL database, retrieve all records from all tables, and ultimately create a script that will recreate these tables and populate their data in a PostgreSQL database. Let's create a console application and add a reference to the SqExpress library from NuGet. The first step is to create a database object that manages the SQL connection and passes the generated SQL code to SQL commands. To initialize the database object, we need to provide an instance of SQL connection with a specified connection string. In our case, this connection string points to the well-known sample database Northwind. The second argument is a factory that creates a SQL command using the connection instance and a query text. The third argument represents a desired SQL exporter profile. Finally, the last argument suggests whether the connection should be closed when the database object is disposed. With this object, we can finally call the method getTables, which retrieves dynamic table descriptors from a database specified in the connection. Let's iterate through the collection and write table names to the console. Now we can see a list of all the tables that exist in the Northwind database. The next step is to read every cell of every row from every table in the database and write them to the console. To accomplish this, we create an unconditional select query for all table columns and then asynchronously iterate through all records using the asynchronous iterator recently introduced in C# and adopted by the SqExpress library. For each record, we iterate through all columns. The column object can read a cell value from a database record in the form of a string literal, which we then write to the console alongside the column name. Now we can run the console application and see all the database data, which did not fit to the console buffer, as the database quite large. However, it is not a problem as we are going to replace the console output with a file stream that will write our output to some file on a disk which will be recreated each time we run the application. Let's begin by writing statements to create a database table. Each table descriptor includes a script property with methods for generating basic scripts related to the table. We can execute them or convert them into SQL code, and our current goal is the code. To obtain SQL text in the desired dialect, we need to use a SQL exporter. In our case, it should be an exporter for PostgreSQL. The important note is that MS SQL and PostgreSQL use different default schema names. Therefore, we need to specify a default mapping between them. Now we pass the SQL exporter to the method that will return actual SQL code for creating a table. However, before creating tables, we need to ensure that they do not currently exist. The most reliable way to achieve this is by attempting to delete them using the drop if exists script. The SQL database returns tables ordered according to their positions in the dependency hierarchy. To remove the tables, the order should be reversed. Now that we have script statements for creating tables, it's time to generate insert scripts to populate the newly created tables. For each table descriptor, we need to create a list of records of AST nodes that will represent cell values. However, we're not fully done with the table yet. I just remembered a significant difference between MS SQL and PostgreSQL index names. In PostgreSQL, an index name must be unique across the entire database. Let's modify each table descriptor and provide a unique name for the table indexes. To achieve this, we can provide a Lambda function that retrieves a list of existing indexes and generates a list of modified ones. Let's update each index name so that it consists of the table name and the original index name. Since each table descriptor is an immutable object, we need to replace the original descriptor with a newly modified one. Now we can finally return to the insert statements. For each table row we receive from the database, we create a list of AST nodes that will represent the row cells. The list of nodes should be appended to the records list, which will contain all the table data. Each table column descriptor has a method called fromString that can create an AST node from a value string literal. We use this method to populate the list. Now we can proceed with generating an actual insert statement for each table that contains at least one row. The SqQuery Builder includes an identity insert into method that allows performing insertions even into auto-incremental columns. This is important for maintaining data consistency between tables connected by foreign keys. Let's use the records list as values for the insert statement and invoke the familiar to SQL method with the PostgreSQL exporter. Now we can append the resulting SQL code to the file stream we created earlier. To separate each insert statement, we need to add a semicolon symbol to the end of every statement. Now we can run the application and observe what was added to the file. Let's switch to pgadmin and create a new database where we'll apply the generated script. Once the database is created, let's open the generated code and reformat it to examine its content. We can observe all the necessary create table statements at the top and insert statements at the bottom. Let's execute the script to ensure that the database was created correctly. In the table list, we can observe that all 13 Northwind tables have been successfully created, and we are now able to select data from any of these tables. It appears that we've achieved our goal, successfully migrating data from an MS SQL database to PostgreSQL using the capabilities of the SqExpress Library to obtain database metadata. That's all for today. Thank you for watching.